Hey there, science fans, let's talk steel. It's one of those materials that we often take for granted, but it's absolutely crucial to our daily lives. It's everywhere, right? From our cars and buildings to bridges and bicycles. Just look around and you'll see steel in action, supporting and shaping our world. Steel is essential for our modern world. Without it, our cities and infrastructure would look very different. It's strong, durable, and we can recycle it over and over again. This makes it not only versatile but also a sustainable choice for construction and manufacturing. But here's the thing about steel making: it has a dirty little secret. The process isn't as clean as we'd like it to be. See, steel is made from iron, and to get iron we need to extract iron ore from the earth. Iron comes from iron ore, a rock we dig up from the ground. This mining process itself can be quite disruptive to the environment. To turn iron ore into iron and then into steel requires a lot of energy. This energy-intensive process is a major factor in steel production, and traditionally that energy has come from burning fossil fuels. This reliance on fossil fuels is a significant issue. That means making steel releases a surprising amount of carbon dioxide into the atmosphere. This is a major contributor to global warming. CO2 is a greenhouse gas, and greenhouse gases trap heat and warm up our planet. This warming effect has far-reaching consequences, and as we all know, a warmer planet means bigger problems for everyone. From rising sea levels to extreme weather events, the impact is profound and widespread. For centuries, we've been making steel the same way, with a giant furnace called a blast furnace. This method has been the backbone of industrial progress, fueling the construction of everything from skyscrapers to bridges. Think of it like a giant oven that reaches incredibly high temperatures, often exceeding 1,500 degrees Celsius. These extreme temperatures are necessary to melt the raw materials and facilitate the chemical reactions needed to produce steel. Inside the blast furnace, we mix iron ore with coke, a type of coal. This mixture is essential for the chemical reactions that will eventually produce molten iron. Burning the coke heats up the furnace and creates carbon monoxide. This gas plays a crucial role in the steelmaking process. The carbon monoxide then reacts with the iron ore, pulling the oxygen away from the iron and releasing, you guessed it, more carbon dioxide. This reaction is fundamental to converting iron ore into usable iron. It's a bit more complicated than that, but you get the idea. The entire process is a marvel of industrial engineering, yet it comes with significant drawbacks. The problem is, for every ton of steel produced this way, we release almost 2 tons of carbon dioxide into the atmosphere. That's a lot. This massive carbon footprint is a major concern for environmental sustainability. In fact, the steel industry is responsible for about 7% of global greenhouse gas emissions. This staggering figure highlights the urgent need for cleaner, more sustainable methods of steel production. That makes it one of the biggest polluters on the planet. Addressing this issue is crucial for combating climate change and protecting our environment for future generations. So how do we solve this problem? How do we address the environmental impact of steel production while still meeting the demands of our modern world? How do we continue to use steel, a material so vital to our way of life, in a way that is sustainable and eco-friendly, without destroying our planet in the process? The traditional methods of steel production are major contributors to pollution and climate change. Well, scientists and engineers are hard at work developing new, cleaner ways to make steel. They are exploring innovative technologies and alternative materials. And one of the most promising solutions is something called green hydrogen. This revolutionary approach could change the game for the steel industry. Remember how I said the traditional method uses coke to create carbon monoxide? This process is not only outdated but also harmful to the environment. Well, green hydrogen can do the same job, but without releasing any CO2. It's a cleaner, greener alternative that holds great promise. Green hydrogen is made by splitting water molecules, H2O, into hydrogen, H2, and oxygen, O2, using renewable energy sources like solar or wind power. This method ensures that the entire process remains environmentally friendly. This process is called electrolysis, and it's like magic. It's a fascinating and efficient way to produce hydrogen without any carbon emissions. It's how we can get clean hydrogen. This hydrogen can then be stored and used in various industrial processes. When this green hydrogen reacts with iron ore in a special furnace called a direct reduced iron, DRI furnace, it initiates a cleaner reduction process. It takes the oxygen away from the iron, just like carbon monoxide does in a blast furnace. The byproduct? Water vapor. This is a significant improvement over traditional methods. That's H2O, folks, harmless steam. This means that the steel production process can be much cleaner and more sustainable, paving the way for a greener future. Section 4. A breath of fresh air for steel. Using green hydrogen in steelmaking is a game changer. It could reduce the carbon footprint of the steel industry by a whopping 95%. That's huge. And it's not just about green hydrogen. Another promising technology is the electric arc furnace, or EAF. EAFs use electricity to melt scrap steel, which can then be made into new products. If the electricity used to power the EAF comes from renewable sources, then this method is also virtually carbon-free. Together, green hydrogen and EAFs have the potential to revolutionize the steel industry and help us build a more sustainable future. It's like trading in our old gas-guzzling car for a shiny new electric vehicle, but on a much larger scale. Section 5. The challenges of going green. Of course, no scientific advancement comes without its challenges. Right now, green hydrogen is still more expensive to produce than traditional hydrogen, which is made from natural gas. Building the infrastructure for producing and transporting green hydrogen also requires significant investment. But here's the thing about new technologies. They tend to get cheaper and more efficient over time. As we continue to invest in research and development, and as the demand for green hydrogen grows, we can expect the price to come down. Section 6. A sustainable future for steel. The transition to a more sustainable steel industry won't happen overnight. It will require collaboration between governments, industry leaders, and researchers. We need to invest in research and development, build new infrastructure, and create policies that encourage the adoption of these cleaner technologies. But the future of steelmaking is looking bright. Imagine a world where the steel that makes up our cities, our transportation, and our everyday lives is produced without releasing harmful greenhouse gases into the atmosphere. That's the future we're working towards, and with innovations like green hydrogen, that future is within our reach. Stay curious, everybody.